Okay, today I want to talk about multi-agent architecture patterns, and most of this talk is inspired by this article released by Amazon Web Services, or as many of us know it, AWS, and it really just tries to do a survey of the different patterns that have been put forward, and none of them is really a one-size-fits-all, but it's important for you to actually know the different types of patterns that have been established and evaluate whether they will work for your use case. So I'm scrolling down here and I'm skipping past the parallel pattern because I think most of us already are familiar with the sequential pattern. And let me just try and zoom in here. It seems the images are not as clear as I expected, but I hope you are kind of getting the picture of what's going on here. So this pattern really it's probably one of the simplest patterns when you are starting to build applications either using LLMs on their own or LLMs with tools. So what happens here is you receive a user's input and then you pass that input through multiple steps to produce some requested outcome. So a good example of this would be if you were building a writing system, a blog writing system, which uses AI agents. For example, the first step would be to do some research on the web. You could give a prompt like, I want to find the top 5 stories in the energy space today or this week. And then once you get the output from that, you then pass it to the writing agent, which you then instruct to say, use the following research output to generate a compelling article for a particular audience. So I would assume that many of you who are listening here have in one way or form worked with a pattern similar to this. Okay, and then I would then go back now to the parallel pattern. So in the parallel pattern, what happens is instead of you doing each step sequentially, you want to run different steps at the same time, and this could come in handy in cases where the output from one stage does not necessarily need to be fed to a different stage. So you would, when you receive an input, you would then send it to 2 or more processing paths, and then in each of those paths you will then run a different workflow, and then you will aggregate the results on the other side to produce the final result. And as you will know that as you might have guessed, arranging your agents like this means that you will need at the output step to incorporate some aggregation methodology so that you consolidate the outputs from each of the paths that you are going to break down your task into. So one example I can think of that would benefit from a pattern like this would be an agentic RAG system that needs to read data from multiple sources. So when a query comes in, you can then say you're gonna break the query down into 3 search queries. One, you search the web, and then another one you can search some documents that are relevant to your organization, or you can search even your databases if necessary. So it's a very useful pattern for situations like that. But yeah, just be careful and just make sure that you are aware that you will need to coordinate the different agents so that you consolidate the results to give a reliable final output. And just on as a side note, there is also a risk that if you run a system like this, for example, for information retrieval, there is a possibility that each of the paths will return information that's slightly conflicting with each other. So you need to design your system such that you are able to handle such cases properly. Okay, moving on to the next pattern, we will look at the loop pattern. So if you are following the AI developments, you will know about a concept called self-reflection, where instead of you having to tell the LLM to think about its answer and self-check its responses, you will then implement a loop where with each run, the LLM will use another more knowledgeable LLM, maybe an LLM that's connected to the internet to correct the responses that comes from the first LLM, and you can set that to run up to a maximum number of turns until we get a satisfactory response, or until we reach an exit condition where we can return a timeout to the user, or a fallback message like, unfortunately, I'm unable to assist with that. So it's a very simple pattern and very useful in having LLMs sort of do self-verification in their outputs before you incorporate maybe an extra sort of verification step there that involves humans. So the other applications where you could use this is maybe in applications like credit scoring models, where you want to continuously improve credit risk models by evaluating performance against the actual outcomes. And I say credit scoring models, you could actually even use this to optimize, to automatically tune hyperparameters of normal machine learning model, any machine learning model, where you have a target score and you have the data. So you can set this loop so that it runs until you reach some sort of a satisfactory threshold in terms of performance in there. So a very important pattern to have in your arsenal when building multi-agent systems. Moving on to the router pattern. This is also a very common pattern that actually most LLM providers use. If you use something like ChatGPT, for example, you would have seen that if you just go to ChatGPT and say, please create for me a thumbnail for my YouTube video, it automatically routes your query to the image generation model, and then it will start generating the image for you. And on the other hand, if you upload a PDF, or maybe not a PDF, a CSV file, and ask it to run some calculations on the data set, it will then call the data analysis agent. So what is happening is that they are using probably a modified version of this router pattern that analyzes the initial query and then decides where to send the query for processing. It's very useful in applications where you want to enable users to do multiple things, but provide a unified interface to improve the user experience there, that users don't have to access multiple applications to do the different tasks that they want to perform. So a very useful pattern to know. And in real world applications, you could use it for a lot of things. Like if you're building a translation application, for example, you could have different agents that know different languages best. And then when the user's query come in, you will then decide which of the agents will be positioned best to answer the user's question. So we usually call the main agent that receives the initial query the triage agent, or the orchestration agent, and then the other agents that going to do the actual work are called the sub agents or specialist agents, etc. In fact, Anthropic recently released a blog article where they outline how they build their multi-agent research system, and they basically used a router pattern in their agent. So it has one main lead agent, also called the orchestrator, and then this lead agent can delegate tasks to other agents. But the difference here, just know that this is kind of a mixture between the routing pattern as well as the parallel pattern, because it's possible that when a user asks the lead agent to do research on a certain topic, the lead agent can actually call multiple sub-agents or multiple specialist agents at the same time. So this is kind of a mixture between the router pattern as well as the parallel agent pattern. All right, I hope that makes sense. If not, please feel free to leave your questions in the comments below, and then we will make another video to address them. Okay, so the next pattern here that they talk about is the AI aggregator pattern. So in an aggregator pattern, we are really just saying we're gonna receive a query, and then we're going to run it against different workflows, different agent workflows, and at the end we will then aggregate the results and give the output. And then the diagram here is probably a bit confusing, but think about a use case like fraud detection, where you will want to check for different things so that at the end you are able to come up with a score of whether the combination of behaviors that you're observing constitute fraud or not. So it's a very useful pattern, and actually in the fraud use case is a perfect use case for it's a perfect use case for this aggregator pattern, but there could be others as well. But the idea here is you are saying you want to combine inputs from different places in order for you to reach an outcome. Okay, so I hope that makes sense on the aggregator pattern. The next pattern that AWS talks about here is called the network architecture, and the basic premise of this architecture is basically setting up the agents to communicate directly with one another in a many-to-many fashion. And in most cases, for you to achieve this, you need something like an event grid system, where the different agents will publish events, and the other agents can either subscribe to the events that they care about and then send responses to different topics that will then be picked up by other agents. And I'm sure you are noticing that this is it requires careful planning in terms of orchestrating all these different events, but it could be useful in some scenarios. For example, see AWS here also lists some pros and cons of this kind of a system. Obviously, you'll know that if you use something like a message broker or an event grid, you are then able to distribute your different agents across different environments. So that's one of the pros also that AWS lists here. There is fault tolerance, of course, adaptability, and it can also enable very innovative problem solving, because the different agents can attempt the problems at using their different kind of areas of expertise. And the cons, the communication overhead, the different interactions, of course, will create a lot of communication traffic. Coordination is one of the big ones, and we touched on that a few moments ago, that you need to think about this carefully in terms of what talks to what and when do you reach a terminating condition, so that you don't end up with very long conversations that are just repeating the same thing or going down the wrong path. So very important to think about coordination before you opt for an architecture like this. In most cases, in most practical cases, in our case, we find that you probably don't need this for many use cases that AI is able to do well at the moment. So only use it if you really need to. And of course, there's unpredictability and there's the debugging complexity, as you might expect. So think about it and decide if you would want to have this kind and decide if you have the risk appetite to deal with this disadvantages listed here. Okay, so I hope that makes sense.